All right, thank you very much. So in my group, we look at Pseudomonas aeruginosa, well, prophages of Pseudomonas aeruginosa, so a little bit different. But I'm glad they've been mentioned already today by John as potentially interesting in therapeutics. Ravathi and Enrique and Heather later on are going to talk more about our work. So I'm going to talk about our science communication work. I'm glad that Martha has already mentioned the government inquiry that has now taken place. I think that there's probably, most of us in this room have probably had some kind of hand at responding to that inquiry. So we're really looking forward to the responses. It's really good news. It tells us that phage therapy is having a bit of a renaissance. It's coming back into the public psyche. MPs are aware of it, and there seems to be a drive towards interest, particularly because of the threat of AMR, an interest in phage therapy. But as we all know, we don't have enough funding, and there are a lot of unanswered questions. So I'm hoping that the findings of the therapy and their response will take that on board, and hopefully there'll be a boost at some funding. So not only the inquiry, but also there have been some big high-profile success stories in phage therapy lately, as well as Tom Island's, who's bought the Good Virus book yet? I've bought it, I haven't read it yet. So we're getting popular science books about phage, and also The Salt in My Soul, which I haven't seen, but I think probably many of you have, this really touching story of someone with cystic fibrosis that didn't get phage therapy. So phage therapy is in the public domain. People know about it. People understand bits and bobs about phage, but I think that it's our responsibility to develop tools that help those conversations about phage, people that aren't necessarily experts in the field. And so this is what we've been trying to do. We've got these outside so you can have a play around with these later on. But what we wanted to do, we wanted, okay, it's all very well giving a talk and we're all amazing speakers, but nothing beats just having hold of something that's got a bit of weight to it. You've got something in your hand and you can play with, and I think we find, we do a lot of teaching and students learn so much better by doing and having a go at themselves. So we've developed these models. These are 3D printed and designed by our makerspace in Salford. And what you can see, obviously, is two wonderful Pseudomonas aeruginosa cells that Ravathi and Andy are holding. And what they've got in their hands, they've got some different phages, and the phages have got different shaped tails, and what they've got to do is search for the right phage that's going to be able to correctly infect the bacterium. So unless they're really lucky, they're not going to find the right phage first. So they have to try this, them screening, trying to find the right phage that will bind to the right receptor. But at some point, they're going to find the right one, and they should see, hopefully, so that it releases these phages out, and really, obviously shows the power of phages in lysing bacteria. But you can see that we've also paid attention to lysogenic conversion. So Ravathi's model doesn't die. In fact, it grows bigger, it's adapted to its environment, it's better at growing. So this is to demonstrate the two kind of major different pathways of phages and how they can affect their hosts. Thank you very much, Glamorous Assistant. So that's the fundamental principles of how phages can affect their host, and straight away that tells you not all phages can kill their host, and you've got to find the right phage to kill the right host. So that identifies two of the major challenges. But we wanted to kind of give more of a feeling of how phages work in context. So we wanted to build a virtual environment that would show these in a disease situation. So I worked quite a lot with Paul Miller, who has got the coolest job in the world because he's an immersive artist, but this is his studio, and it's got all kinds of guitars and gadgets and wires and stuff like that. And along with Richard England in Reflex Art, he's developed a virtual reality lung. So we're Currently, it's not quite ready to have on headsets. We've got a trial of it. It's on a massive computer at the moment, so we haven't brought it with us today. But we're getting this onto the latest VR headsets. And so what they've developed is this virtual reality lung in which you have to choose which bronchiole you're going to go down. And then we've got these two protagonists, Pseudomonas aeruginosa, and several different phages that you meet on your journey through the lungs. So this is just a quick kind of preview of what it feels like when you're in there. It's very moving immersive when you're actually in there. So you go in, you go down, you zoom in, and you see these pools of mucus where you've got your polymicrobial community. And you see several different types of phage infections. So this is the lysogenic infection, and you see that there's some bacterial effects happening. And then later on, the lytic phages come in, and then I've stopped it there. So you're not seeing the lytic events. You have to see the app, you have to come and see the app later on. So that's what we've developed, and we're very, very close to getting it on the headsets, and I will share it when we have it there as open source. So we took those two things, we took them to the Royal Society Summer Science Exhibition, which is quite high profile, down in London. And you can just about see in behind Enrique there, that's the magic lytic event that was happening up on the screen in the room. As we took it to the Royal Society, we had, there's about 6,000 visitors. So we had lots of engagement and lots of conversations about phages. I mean, we had a real fantastic time over the week. We had some little cards with surveys. And of the people that filled in the survey, about 90% learned something new about phages. 40% have never heard of phage before. So this is a win. We got a fair bit of media attention, particularly the BBC Health Check of the World Service came and interviewed us, and that kind of went global. So we were quite pleased that we'd had a fair bit of impact. If you want any tattoos, we can provide those. The great thing about tattoos is that during that event, when we were talking to people, we were giving them a tattoo, you've got a captive audience because you've got hold of them and they're not moving for at least 2 or 3 minutes while you put a tattoo on them. And so that really encourages deep conversations. And not only did we talk to schools and teachers and general members of the public, there were members of Parliament that came and FRSs that came. In general, though, they were all already interested in science. So really, we're not reaching the general audience. And so we're at Salford, we're right by Media City. We do have quite an outlet and an opening to normal people. And so we got an opportunity to showcase our work at Lightwave, which is an art exhibition. It's nothing to do with science. And we decided to go bigger, and we built a massive phage, which is about this big. And we built it with a basic frame, and then we projection mapped onto it. And we created a room, which is the size of this room here, in which people could have this very personal and immersive experience. We've got surround sound in the room, and the projections and the sound are motion sensitive. So anyone that goes into this room, depending on how they move, they get a completely unique experience, which I think really mirrors the phage world, and that every time you encounter a phage, it's something for you there. And this is the artist's interpretation of how phages are so tiny and the universe is so massive, but there's more phages in the world than there are stars in the sky. And so there's lots of things here that I think, well, really make my heart leap anyway, and probably yours as well. So along with that, so we have people that came in, we could have about 20 or 30 people in the room at any one time. So we had activities around the room that other people could do. And we worked with our media students who were particularly interested in reaching younger audiences. So they had developed a series of cartoons. So I had a couple of sessions with these art students, so they're not scientists at all. These are undergraduates, so between 18 and 21-year-olds, learning about animation. So I came and chatted to them for about half an hour about how amazing phages are, and I talked about the different, some different aspects of phage biology. And then for their assessment, they had to produce a 1-minute video. So they picked up on different aspects. So Martha's already mentioned this. We talk about this a lot, don't we? That there's amazing untapped resource, and they're the most abundant thing on the planet. And in a litre of seawater, there's 1 billion virus particles. So this student picked up on that, this watery environment, and I think it really beautifully shows the power of phage that come and inject their DNA into their specific host, and then they burst it open with this dramatic effect. And I think that shows really beautifully this power of people to really grasp onto that about how phages could be used as therapeutics. Another one picked up on how natural size phages were laid into it, was just 2 million light years. So set it in space, and I'm really impressed at the mechanism of injection here, just one, as the phage comes in and bam. And then inside the space station, you've got all these bacterial proteins and phage and locked in. And I think that that really beautifully represents an event that what happened. So some of them picked up on how we've got our own phages in our own body. So in our microbiota, phages help to control the ecology of microbial communities in the body. It's a really nice concept that grabs people's attention because then it personalizes it for them that they've got phages in their body. So lots of our students created battles that were internal. This one here is maintaining a healthy microbiome. So this was where the blues were the good, were the healthy microbiota, the red was the pathogen. But I really like that completely different interpretation. This is working, so this is our antibiotic. Poor little antibiotic is you know, really, these are really fun. You can see that they're targeted to kids, but actually they represent all of these different factors really well, and that we're not proposing phages on their own, but phages working together with antibiotics as treatment. So that's lysis, but of course we all know that that's just one role of bacteriophage, and that we have temperate phages that are also are much less well understood. I want to show you this one. I'm not going to make it, see what you think. This is adaptation of a So that one's really quite touching, and it shows how phage infection can actually help the bacterium to adapt to its environment. I've got one more. I hope I've got time for it. This one is interesting because the students ran out of time. They had a very short amount of time to do this. So the end of this cartoon is quite unfinished. But actually, I really like that because, well, phage research is unfinished, right? And there's all kinds of stuff that we still haven't quite got the full picture yet. And so it starts off with a hard day at the office for this phage. Do his day-to-day job. I think this must be strep pneumo. Clearing out full of mucus noise inside the cell. This is the unfinished bit where the phage gets a new assignment. And this is this idea whereby phages, okay, maybe they're not going to kill the bacterial host, but maybe they can temper the infection and make it less virulent. So this is this idea that they could be an antivirulent factor. So I think the students, this is non-scientists, and I think they did fantastically well at coming up and picking up. I've probably overinterpreted them a little bit, like an English literature student just interpreting a poem to death. We showed these cartoons at the Lightwaves Festival, alongside having this workshop where you've all built your own phage out of these origami templates, I'm sure. And this was near Christmas time, so we built Christmas tree decorations that people could hang up. And this activity took about 20 minutes. So again, we got these really rich conversations with people. We didn't just invite the general public. We had a closed session where we invited clinicians to come along. And I was really glad that John, you mentioned that you'd sort of spoken to physicians about their perceptions of phage therapy and what they know and what they'd like to know more about. And even though these activities are fun, actually, I think that they have some real serious use. And I think, you know, if any of you would like to use any of these activities and evaluate people's opinions, then we would really like to share these, because it provides an environment that is welcoming, that people want to hang around for a while. The feedback that we got from this was that people enjoyed it, they thought it was amazing, but they also thought that it was quite relaxing and they wanted to stay and they wanted to talk about phage for a long time. So people like MPs, people who aren't scientists, may well want to stay and have longer conversations in these kinds of environments. It's kind of summed up by this tweet, and I promise I have no idea who this person is, but they said that they genuinely learned more about cystic fibrosis from 5 minutes at this art than they'd ever picked up from any other resources, and they also need these phage bulletins. And so that hopefully is showing you the power of these kinds of tools. So obviously a huge number of people were involved in this work. This is a picture of us outside the Royal Society on a sunny day. So we do really enjoy developing these tools outside of the lab. Okay, that's everything. Thank you very much.